Let us solve question 4 and question 5 together. So there's a reason I am solving these two questions together, because I want to show two different methods wherein one can prove or show that the given transformation are canonical or not. So in question 4 we are going to go with the symplectic condition to show that the given transformation is canonical, and in question 5 we will go with the Poisson bracket to show if the given transformation is canonical or not. Okay, so the question given in the fourth question given to us is capital Q is given by log 1 by q sine p and capital P as q cot p. So this question is referred from Herbert Goldstein's Classical Mechanics Indian edition. Okay, now we have to show that this transformation is canonical. So as I said in the question 4, we will be using the symplectic condition where M is the Jacobian of capital Q, capital P and small q, small p. Alright, this Jacobian is defined by this partial derivatives, and once we put the values of capital Q and capital P at the places and take the partial derivatives, we will be having a matrix that is given by this condition, that is matrix minus 1 by q as 1 comma 1 element. The second will be cot p, so this is a cos p by sin p, that is cot p, and again a cot p on 2 comma 1, and finally minus q cosec square p. So this is our Jacobian which we have formed for this particular transformation given by capital Q, capital P, small q and small p. Alright, now what we say in the classical mechanics, that if our Jacobian matrix is following the condition of the symplectic condition, then the transformation which is represented by this Jacobian is canonical. Alright, now I am taking the left hand side part of this condition, so M into J into M transpose. Alright, so as of now I have kept M over there, and this is the J. J is a kind of spatial matrix that proves the symplectic condition. Alright, now this is the transpose of M, that is minus 1 by q cot p and minus q cosec square p, and this results in cot p plus 1 by q minus q cosec square p minus cot p. And once again I will multiply this matrix with the M matrix over here, and what will be left with me is just 0, 1, minus 1 and 0. So this is nothing but equal to J. Alright, now this tells me that this given transformation is canonical. Reason? It follows the symplectic condition. Alright, so this is the fourth question. It's a very small question, and now we will move on to question 5. The question 5 is kind of similar, wherein we have to show that the given transformation is canonical. Alright, so the transformation is given as capital Q equals to tan inverse alpha q by p, and capital P is alpha q square by 2 into p square by alpha square q square. So this is our transformation given. Alright, now I define a Poisson bracket over q, capital Q and capital P with respect to small p and small q. Alright, so I have my definition of Poisson bracket is this: partial derivative of capital Q divided by partial derivative of small q into partial derivative of capital V with respect to partial derivative of small p minus partial derivative of capital Q divided with respect to small p, and partial derivative of capital P with respect to small q. Alright, this is the definition of my Poisson bracket. Now, when my Poisson bracket of capital Q and P equals to unity, that is, if capital Q and capital P equals to unity, then my transformations will be canonical. Alright, and I will go on to solve, find these terms first. Capital Q by small q is nothing but alpha p upon p square plus alpha q square. Capital Q by partial derivative of capital Q by small p is minus alpha q p square plus alpha q square, and similarly the other two. Right, now I substitute all of these four values into equation 3 over here, and I will get the result as alpha p upon p square plus alpha q whole square into p by alpha and minus alpha q minus of minus alpha q upon p square plus alpha q whole square into alpha q. Alright, this will be nothing but p square plus alpha q whole square upon p square plus alpha q whole square. Okay, and because these alphas will get cancelled and the numerator and denominator are same, so our Poisson bracket is a unity. So as we have said earlier, if the Poisson bracket of given two variables as a unity, then the transformation would be canonical. Alright, so these two approaches, the one that is shown in question 4, that is to the symplectic condition, and the one that is given for question 5, they are quite different approaches, but results they lead us to the same results. Alright, I hope both of these methods are clear, and especially the one with Poisson bracket, because that is not very used to the process in the field. So thank you.